A common metabolic assumption is that fasting or steady-state cardio will effectively deplete localized muscle glycogen, but in our previous segment, we looked at a physiological mechanism that explores why that may not be the case. Available observations suggest that skeletal muscle lacks the glucose 6-phosphatase enzyme. It acts as a strictly localized vault for carbohydrates. Therefore, from a physiological perspective, maximizing carbohydrate efficiency is interlinked with mechanical stimulus to access specific energy stores, which is metaphorically wringing the sponge. But whether you rely on fasting, cardio, or mechanical tension, it may influence the metabolic outcome. Based on this, we explore 3 common approaches with regards to accessing stored carbs and the metabolic relationship of each. First, exploring systemic energy deficits through fasting and carbohydrate-restricted diets. A common physiological assumption is that, for generally healthy adults, fasting may systemically use excess stored carbohydrates overall. But sources suggest that although fasting may effectively use liver glycogen to stabilize baseline blood sugar, however, muscle stores may remain largely unused. During a fast, under healthy circumstances, the body intelligently shifts to fat oxidation, specifically to preserve stored muscle glycogen in case of a potential need. So, while fasting may create a systemic deficit, it may not necessarily access the localized muscle sponge. Next, we have steady-state endurance, or Zone 2 cardio. This is undeniably valuable for building a robust cardiovascular base. But when it comes to localized glycogen depletion, we have to look at the energy systems involved. Passive cardio relies almost entirely on the oxidative system, which is incredibly efficient at burning free fatty acids while intentionally sparing our high-octane carbohydrates. A moderate 45-minute jog may simply not generate the anaerobic demand required to fully use the carbohydrate stores in the working muscles. Finally, the application of targeted mechanical tension creates a specific muscular demand. To sustain this effort, the muscle shifts away from the aerobic system and relies heavily on glycolytic pathways, the stored carbs. When a healthy muscle is under sustained anaerobic load, it can activate its cell to burn through stored glucose to complete the work. The mechanism involved are GLUT4 receptors. When carbohydrates are reintroduced, they are prioritized to replenish the depleted muscle stores, influencing hypertrophy. It provides a profound shift in perspective based on individual suitability and health status. Go deeper and subscribe for more holistic high-performance health.